So this is what we have done. So first thing is, what I have done is, I have imported the libraries NumPy, Panda, Seaborn, linear regression, metrics, Matplotlib, PyPlot at PLT. Okay. Then this particular admission dataset, what I am showing it to you, I have downloaded it from this particular site. Okay, kaggle.com. Okay, admissions.predict. So initially, if you download this dataset, it will be in the form of 1 and 0. Okay, that is yes means 1 and no means 0. I have changed wherever 1 is there, I have changed it to what is it, wherever 1 was there, I have changed it to yes, and no is there, I have changed it. Wherever 0 was there, I have changed it to no. That's all. Okay, that's a simple thing what I have done, and I have got this in the form of a yes or no. Okay, just for better visualization. Okay, so I have stored this particular data set over here. If you look at my file, can you see admissions.predict? Okay, so this is the path what I have given it over here: C user admin desktop ML Python, and I am reading this particular data set. Okay, I'm reading this particular data set and I'm storing it into a variable called as a df, data frame, df. Now I am printing the shape of this data frame, information and head. Okay, so what it does, so if you look at this, there are 400 records. Okay, there are totally 400 records over here. Okay, you see there are 400 records over here, and how many columns? 1 2 3 4 5 6 7 8 and 9, and ninth column being the chance of admit. So that is what it is showing over here. Okay, 400 entries. Okay, total number of columns is 9. Okay, and it is also displaying what, that is what type of variables it is holding. Okay, this is an integer variable, integer variable, integer variable, floating point variable. Okay, floating point, integer, and object variable. Okay, that is what it is showing over here: integer variable, floating point, integer, and chance of admit, which is yes or no, object, right? Memory usage size, all these things it is displayed over here. Okay, now, what am I going to do here is, here I am just explaining you what have been taught to you in the previous class. Okay, logistic regression. I have told you to do an exercise, and I am just demonstrating you. Okay, because I don't know like whether how many of you have done or not. I have not checked. Okay, so but if you have not done, you can follow. You can take any data set and follow. And I have told you what you are supposed to do. So on this particular data set, what I have done is, okay, on this particular data set is, what I've done is, if you see here, how many of the people have been admitted? Okay, so actually, okay, actual admission have happened on the particular data set. Yes. So if you see, there are so many yes over here, and only very few no's are there. The majority of them are yes, and can you see, there are everything, almost everything is yes, and there are so very majority is no. So how many of them are yes means print df chance of admit. That is, chance of admit means what? Let me just, okay. So chance of admit means this is the column name, right? The column name I have given. The chance of admit equals to yes. That's all I have given. Equal to yes count. So if you see, 367 records in total are telling yes. 367 records have been yes. Okay, that is 367 students have been admitted into the universities. Okay, fine. Okay, now what am I going to do is, I am going to plot the linearity, okay, between GRE, TOEFL and GRE, then university, TOEFL and to GRE, then SOP to university, TOEFL, GRE, okay, then LOR, then CGPA, okay, that is interlinearity among the variables, okay, among the attributes we can say. So you people have been doing this, okay. So if you look at this one, serial number, to research, okay, to the segment. See, a serial number is not going to play any major role in predicting the output, whether the student is going to get placed. So in the upcoming code, I'm going to drop this particular column, and from these column alone, I'm going to take. Okay, these column alone I'm going to take, because serial number is just a random number, right? Which does not provide any information. It does not add value to the data set. Okay, so see, I have plotted so GRE with respect to CGPA, TOEFL with respect to CGPA and GRE. So I am checking the You see, I'm checking the pair plotting. I'm pair plotting the values. Okay, now I am doing the correlation. Okay, correlation and viewing the result through heat map. Okay, heat maps. So, see here, GRE score. Okay, GRE with respect to research, GRE with respect to CGPA, GRE with respect to LOR, GRE. I have told you how to do I have told you how to do all these things. Okay, how to check the heat map. Okay, what is the correlation? Okay, kindly please refer my videos. What values it should be for a better correlated values. Okay, better for a better correlation. What values? What is the range? I have already given it to you. Okay, so I'm just checking those values. Okay, now in this particular column, as I told you, column is not going to play a major role, so I'm going to drop the column and I'm printing the again the data set frame. Okay, so data set frame, if you see the column have been dropped, that is the serial number have been dropped. Okay, the serial number have been dropped. This is the normal one. The 0, 1, 2, 3 is a self-generated serial number. But if you see over here, this particular column have been dropped. Okay, it is not required. Okay, now what am I going to do? What am I going to do? Among these data sets, is there any missing values? Is there any missing values? Okay, just something like this. Okay, is there something like this? Okay, any missing values? Okay, I will just write it down. Okay, something like this. Any missing values? Okay, or else is there something like this? Any missing values? Okay, is there something like this? Any missing values? Okay, so if you look at it, okay, I'm just checking whether the particular values are missing or not. When I'm executing this, everything, can you see the entire data set has filled with values. There is no missing values. There are no null values in all the 400 records. Can you see? There is no null values. There are no null values. There are no null values. So it is printing everything, okay, TOEFL score, all the columns, okay, all the column values, whatever we have been taken into consideration, like GRE, TOEFL, University, SOP, LOR, CGPA research, everybody has 0 null values. Okay, now what am I going to do? Okay, now I am applying the linear regression, logistic regression model. Okay, logistic regression model. So now here, if I am seeing this one, so I am taking all the rows. That is, the colon means, you people have done already slicing also. So I have already told you what is slicing. So if you look at this one, colon means all the rows have been taken. That is, all the 400 rows have been taken. And column 0 to 7 means 1 less. That is 6. That is 1, 2, 3, 4, 5, and 6. That is 0, 1, 2, 3, 4, 5, and 6. Okay, so 0 to 6. Can you see? 0 to 6, 1 less. Okay, always it is 1 less. While I had explained you about slicing, you people should have been knowing that. Okay, so 1, 0, 1, 2, 3, 4, 5, 6. So all the columns have been taken, okay, into consideration. Okay, and what about this one? All the rows and the 7th column alone, which is the chance of admit. So if I try to print the value of x and y, print train x and y means what? So this is the values, right? So this is the 400 records which I have printing. You see, 400 records, till it goes till printing. Okay, and this is the y value, print train y. You see, 400 records which have been trained for printing. Okay, excuse me. Students, are you able to understand whatever I'm teaching you? Hello?
Yes, sir.
How many of you are able to understand? Please raise your hands quickly. Okay, fair enough, students. Okay, so now what am I going to do? Okay, so I have printed the train x and train y. Okay, now see here, if you look at this data set, Okay, it's always better to normalize our data set. I have already told you in the last class also, the last lab also. Okay, so if you see one column value is 337, another column value is 118, another column value is 4, another column value is 4.5, 4.5, then 9.651. Okay, so these are the different ranges. So what we do is to come with the overall data set stability, a uniqueness, a better way is, okay, to always normalize. Okay, and the best normalization, okay, and there are so many normalization formulas, but mostly what people do is we go for min-max normalization. Okay, we go for the min-max normalization formula. So when we apply the min-max normalization formula, every value is in the range from 0 to 1. Okay, every value is in the range from 0 to 1. So all these values, whatever you have been seeing in this particular data set, okay, will be ranged from 0 to 1. And I hope you people know how to do it, okay, by using the min-max normalization formula. I think so last class I have displayed you that formula also, right? Okay, I have not displayed it. So you just apply the min-max normalization formula. Okay, the formula is you take the value of x minus of maximum by maximum minus minimum will give you a range of between 0 to 1. Okay, for that entire column. It's very easy. So like once you do that min-max normalization formula and once your entire data set is ready to be fitting into the line, then you can calculate the logistic regression formula. Okay, logistic regression formula, that is 1 by divided by 1 plus e power of minus x. If it is the multiple regression, you go for m naught x naught plus m1 x1 plus m2 x2 and it goes on. So here we are calculating it for the coefficient. Okay, since there are multiple values, right, multiple attributes, 1 2 3 4 5 6, okay, 7. So 7, so we have 7 question, 1 2 3 4 5 6 and 7, and we calculate the intercept of it. Okay, using the particular formula. Now what we do, we apply the value, we substitute the value of x. When we substitute the value of x, we are able to predict. Okay, we are able to predict. Okay, it gives you the prediction result. Yes, 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 yes. Can you see? This side is the yes. Okay, so this is the actual data. This is the actual data on the data set. Okay, this is the actual data on the data set. Okay, and when we apply the logistic regression, okay, this particular, can you see the second one? The first column is the actual data. This is the actual data which is there. This is the first column. The second column is the predicted values. What the system is predicting for you based on the data set what you have given. Based on the data set what you have given. So when you apply the values of x or of whatever the values of it, the system will predict the y values. Whether the chance of predict is yes or no. Okay, either in the form of a 1 or 0. So we can change it to yes or no. Okay, so now you have predicted the system. Now can you see? Now I'm plotting the values. Now I'm plotting the values between the actual and the predicted. Within the actual and the predicted, and there are some mismatch. Okay, there is some mismatch. Now we will see what is that mismatch. Okay, so I have already told you students last week in a very clear way what is the predicted positive, true positive, false positive, predicted negative, false negative, and true negative. Okay, so when you are predicting positive, when your actual is also positive. Okay, you're predicting negative. Okay, and your actual is also negative. Okay, so like that we can formulate the confusion matrix. If you are not well versed, kindly please refer the last class video. Okay, kindly please refer the last class video. Now what is this, students? What is this about? Okay, so if you see, students, 367 records, okay, we have predicted. Can you see? If you look at this one, this is the first column is the actual one. Okay, and wait, I'll just show you 1 second. If I want to show you, I need to execute the entire stuff. So you can just try it out. Okay, I'll just tell you what is happening here. Here, this is the actual column. Okay, this is the actual column. This is what it is printing here. 1 second. Okay, this first yes, right, is the actual column. And you see, this is the actual column, what it is here. The next one is the predicted column, what our model has given. What our model has given. So in this, students, out of 400 records, out of 400 records, okay, 367 records, okay, the system has also told, that is, we have also told yes, and the predicted is also yes, and the predicted is also yes, okay, and the predicted is also yes, okay. Then 5 records, okay, 5 records, the system have told no, and we have predicted also no. Can you see? The system have told no, the predicted also no. The system have told yes, the predicted also yes, is 367 matching, okay, and 5 matching, okay. Then this 28, the system have told no, okay, the system have told no, okay, but we have predicted yes. Like that, how many records are there? 28 records are there. Okay, 28 records are there. Okay, but the system have told yes. Okay, the system have told us, but we have predicted no. But we have predicted no is 0. This is what the confusion matrix is telling. Now that is what I have explained to you about true positive, false negative, true negative in the last class. So kindly please refer that. You're getting the point, students, what I am telling you? The confusion matrix. What is happening here? Hello? Hello?
Yes, sir.
Everybody is able to follow it up, right? Yes?
Yes, sir.
Yes, sir.
Okay, so if you see this one, it's better I just run this and show it to you. Whatever, I didn't run any command. Okay, done. Done. Okay, can you see, students? Okay, this is the actual data set. Okay, and this is the predicted values. So if you see, there are 367 records which are matching. Okay, 367 records which are telling yes. Okay, whatever we have also, the data set is also telling yes, and our prediction value is also yes. Okay, these are 367 records. Like this, no. Okay, can you see? No, the system is telling, but we have predicted yes. Okay, there are certain number of records. How many records is the system telling here? How many records is the system telling here? Okay, 28 records. Okay, 28 records like that. Okay, like that, 28 records are there. Okay, no, yes. I'll just show you a few more records. Can you see? No, yes. Okay, can you see? No, yes. No, yes. No, yes. Can you see? These are the records. Can you see? No, yes. No, yes. Okay, so if you go down the line, you will find a multiple like that. Okay, so no, yes, no, yes, no, yes. Okay, our system is predicting like that, falsely classifying 28 records. Okay, so 5 records, our system is also predicting no. Can you see? 5 records, our system is also predicting no, and we are also predicting no. Okay, and 5 records are there, and yes and no, yes and no, there are no records such thing like that. So that is what it is. Okay, that is what it is. So if we are predicting positive and the system is also predicting positive, it is a true positive. If we are predicting positive but the system is predicting negative, okay, this is the predicted values. So predicted values means what? This is the predicted values. We know that, right? These are the actual values. These are the predicted values. So last week I have told you, kindly please refer that video. So predicted values, okay, we are predicting positive, but the system is also positive. Okay, so positive, the system is also positive. Fine. Predicting positive, but the system is predicting negative. That is false positive. Okay, so when we are predicting negative and system is predicting positive, so false negative. So when we are predicting negative, but actually it is negative, it is true negative. Okay, so this is the one thing we should know. So like that, if you forming, okay, so if you look at this 367 records, yes, system is also yes. 5 no, system is also no. So 367 plus 5 is 372. So 372 records, if you see, out of 400, so 372 divided by 400, out of 400 records, 372. So the accuracy is 0.93. So if I want to print the accuracy, can you see? The accuracy is 0.93, and this is the confusion matrix. And 28 records we have predicted wrongly. So the same thing can be inferenced in C. So 01, 01, actual label and predicted label. Actual label and predicted label. So actual is also 1, and we are also predicting 367 records. So actual is 0, and system is also predicting 0, 5 records. But actual is 0, but system is predicting yes. Okay, the system is no, but we are predicting yes, fine. But the actual is yes, but the system is predicting no is 0. Getting the point, students? What is happening here in the confusion matrix? Hello? Hello?
Yes, sir.
Yes, sir.
Yes, everybody is able to understand? Hello, everybody
Yes,
is
sir.
able to understand?
Yes, sir.
Okay, that is what is happening here. So now when I am drawing this thing, so can you see these are the blue things which have been predicted, okay, which have gone in a wrongly classified. Okay, I told you, right, some few 28 records, actual and predicted. Actual is 367 and predicted. So this is what it is and how you calculate the logistic regression. Is it very clear now what you people have to do? So this was the exercise given to you last lab. This was what was expected to you, to take any data set which is compromised of a numeric numbers. Make sure it has an input data which is linear, output column should be in a categorical, okay, and apply, you may use logistic regression, okay, use correlation, plotter scatter plot, all those things I have put it in the chat box also. Kindly recall that, and I hope you have copied that also. And this was you were supposed to do it. In case if you have not done in this particular way, kindly please do it. Okay. One second. Okay. So in today's class, we will be quickly going through decision tree. So can everybody put your hands down? Okay. Is there anyone or anything who have not learned decision tree? Raise your hands. Because for Cat 1, you people have studied, right? Is there anyone whose faculty have not taught you decision tree? Any of the faculty not taught you decision tree? No, please understand. Please understand my question first. Is there anyone who have not learned decision tree? Raise your hands. I'm not telling you have learned. Have not learned. Aditya Agarwal?
Yes, sir.
You have not learned decision tree?
No, sir.
Who's your faculty?
Jagannathan, sir.
Okay, so Jagannathan sir, students have not learned decision tree?
Yes, sir, we haven't, sir.
My God. Okay, now what I will do is, I will just explain you a quick summary of it. Okay, so kindly please try to understand what is happening over here, and then once your faculty have taught you, then you will be in a much more better way, because I think so Syed sir and myself have also decision tree, because to teach decision tree itself it took 1 hour for me. So keeping that in mind, please excuse me. Okay, so but I will just explain you what is happening in decision tree, and then you can kindly once you understood the concept, once you have understand the concept, okay, you will be able to adapt, and once you revisit this video by downloading it, you will be able to understand the video in a much better way. Is that clear? Is
Yes,
it clear?
sir. Yes,
Okay.
sir.
Okay. I will just run through, because there are other people who have already learned it, but I'll just give you one glimpse of it. What is a decision tree? Just try to catch hold of the points and jargons. Okay. Now, basically, a decision tree is used for classification. Okay, decision tree is used for classification. So, a decision tree consists of root node, node, and leaf. Okay, so root node over here, these are the internal nodes, and these are the leaf nodes, and leaf nodes will have the outcome. Okay, whether it is yes or no, okay, whether he will play or no, whether he is large, small, tall, whether he is a boy or a girl, okay, whether he will come tomorrow or he will not come tomorrow, okay, whether he will pass or fail. So these are the outcomes, right? So based on some certain conditions, okay, the outcomes of the particular node is happening. Okay, say for example, if it is rainy and it is humidity, and if the temperature is so and so, Raj will play tennis. Okay, so like that you are going to build up the decision tree. So we will see that particular part. So now I don't know, because if I start explaining the decision tree, it will go 1 hour. Please understand. Okay, so I will just explain you what is happening. Okay, see here, these are the attributes. Okay, these are the attributes. So decision tree, what we are going to do is, we are going to use ID3 algorithm. ID3 ID3 algorithm. Based on this ID3 algorithm, okay, we are going to build a decision tree. We are going to build a decision tree. Okay, so we are going to build a decision tree. So you have the data set. In the data set, the first step is what happens here is there are multiple attributes like outlook, temperature, humidity, wind. Okay, so if the outlook is sunny, temperature is hot, humidity is high, and wind is weak. Say for example, Raj will not play tennis. Raj will not play tennis. But if the outlook is sunny, temperature is hot, humidity is high, and wind is strong, again Raj will not play tennis. But if the outlook is overcast, temperature is hot, humidity is high, and the wind is weak, Raj will play tennis. Like that, rain, mild, high, weak, Raj will play tennis. Like that, rain, cool, normal, weak, okay, then the Raj will play tennis. The same way, I have 14 examples, instances, whether the Raj will play tennis or not, in what conditions. So for that, I need to build up a decision tree. So to build up the decision tree, the first thing, the most important thing is to come up with a root node. Now what is a root node? The root node decides out of these 4 attributes, outlook, temperature, humidity, and wind, which attribute contributes the maximum, okay, to the final output, whether he will play tennis or not, whether the Raj will play tennis or not. Say for example, just to make you understand, okay, in a cricket team, okay, there are multiple players, right? Okay, player 1, player 2, player 3, player 4, player 5, and player 11. On a given day, say for example, okay, consider, okay, there are 11 players in a team, 1 to 11. Okay, now what happens is, now finally the team is winning. Okay, finally the team has won the match. Okay, finally the team has won the match. Just to imagine, just to make you understand, the team has won the match. In this winning the match, okay, player 2, player 3, player 4, player 5, player 6 have all scored 0 runs. Player 8, player 9, player 10, and player 11 has scored 11 runs. And player 1, the first player, okay, the opening batsman has scored 200 runs. A double century. Now, at the end of the day, say for example, at the end of the day, the team have won. How will you decide? Okay, which player have contributed the maximum to the team so that the team has won? Okay, it might be negative or it might be positive, whatever it might be. Okay, it might be negative or it might be positive. So, but we are bothered about information gain. That is the most important part of it. That is the most positive part of it. So, for this we can say that the player 1 is the 200. So, player 1 has scored 200 runs, so make him as the root node. Okay, the same thing, this is just to make you understand, in the decision tree, out of these 4 attributes, which attribute contributes the most, okay, for the final outcome, whether the particular Raj will play tennis or not. This is called as a root node. It's called as the root node. Now, to calculate the root node out of all the 4 attributes, we can't just go ahead and do it, right? We have some series of steps. Okay, because we can go either through entropy, okay, through Gini index, okay, but for this class we will go through entropy. Okay, so we will calculate the information gain through entropy, and information gain through Gini index also can be calculated, but we will go through information gain through entropy. Okay, so now what happens is, where is the PPT? Here is the PPT. Okay, so we will calculate the information gain. We will calculate the information gain of the outlook. We will calculate the information gain of the temperature. We will calculate the information gain of the outlook. We will calculate the information gain of the temperature. We will calculate the information gain of the humidity. We will calculate the information gain of the wind. We'll calculate the information gain of the wind. Then the maximum information gain out of all these 4 attributes, okay, will be made as the root node, Getting the point? So now how do I calculate the information gain? Using the concept of entropy. So now what is entropy is, I will explain you only 1-2 slides in a full detail, because there are few students who have not understood anything. It is the same way we built up the decision tree. Okay, it is the same way we built up a decision tree, and you can proceed from there on. Okay, so now what happens is, the first step is, okay, I calculate entropy of the entire data set. Okay, so the formula to calculate the entropy of the entire data set is, okay, minus pi I by 2 log base 2 by p I by 2. That is, what happens here is, if you see at this particular example, okay, how many positive instances are there and how many negative instances are there? Okay, so positive instances means 1, 2, 3, 4, 5, 6, 7, 8, 9. So what I do? 9 positive instances out of 14 examples, log base 2, 9 by 14. Okay, when you sum up, okay, when you bring in the minus sign will be inside. Then negative instances, that is no. So how many negative instances are there? 5 negative instances there out of 14 examples. Log base 2, 5 by 14. Okay, so you calculate the entropy for the entire data set. That is what we have done here. Entropy of the entire data set. Okay, can you see? This is the entropy of the entire data set. Okay, now what you do? Now after calculating the entropy of the entire data set, you calculate, okay, the information gain for 1 by 1. Outlook, temperature, humidity and wind. So for outlook, the formula is entropy of S, that is the entire data set, whatever he has calculated, minus summation of, for sunny, how many attributes are there? For outlook, how many attributes are there? Sunny, overcast and rain. So sunny, overcast and rain. Okay, so I am calculating the information gain for the attribute outlook. Okay, so in sunny, okay, there are, how many records are there for sunny? 1, 2, 3, 4, 5. 5 records are there in sunny. In that, 2 yes and 3 no's are there. That is, in that 1, 2 and 3 no's are there, and 1 sunny yes and 2 sunny yes. Can you see? So 2 yes and 3 no's are there. So the information, the entropy for sunny is, so out of 2, our total number of records is 5. So 2 yes log base 2 2 by 5 minus of 3 no's log base 2 3 by 5. The same thing you will be doing for overcast, and then the same thing you will be doing for rain. Okay, then the same thing will be you doing for rain. Then you will be calculating the information gain, the overall information gain. So the overall information gain formula is given over here. Then you will be plugging in the values. You get the overall attribute, okay, value for the outlook. Okay, then you will get the overall attribute value for the outlook. Then you will calculate the temperature. Okay, the same thing for the temperature. If I tell you attributes hot, mild and cool. So 3 attributes, right? Hot, mild and cool. So in hot, how many yes are there and how many no are there? In mild, how many yes are there, how many no are there? In cool, how many yes are there, how many no are there? You calculate the entropy. And then you substitute in the information gain formula. Okay, so entropy of S equal to 4 by 14. Okay, hot are there, 6 by 14 mild are there, and 4 by 14 no are there. The entropy of hot you have calculated over here, entropy of mild you have calculated over here, and entropy of cool you have calculated over here. Then you calculate the values. Then you plug in. So then you will get the information gain. The same way for humidity you will do, the same way for wind you will do. Then you will have the 4 values. You will have 4 values. You will have 4 values. So the attribute which have the maximum value will be the root node. So in this case, Outlook has the maximum value. So Outlook will be made as the root node. Okay, Outlook will be made as the root node. Can you see? Outlook is made as a root node. Now from that Outlook, we have to say how many attributes are there in the Outlook. So in our Outlook, we have sunny, overcast, and rain. So we will keep splitting the values till we have a particular category, only yes and only no. But if you have both yes and no, then we have to keep further splitting. Okay, then we have to keep further splitting. Is it clear? Is it clear, everyone?
Yes, sir. Yes.
Hello?
Yes, sir.
Clear, everyone? Okay, now why do we go for entropy, students? What happens when there is an entropy? What is a better entropy? Can anybody tell me? What is a better entropy? Yes? What is a better entropy, students? So if the value of the entropy is greater than is nearer to 1 or nearer to 0. Always we know that, right? Entropy fluctuates from 0 to 1. Okay, if it is if the value is producing nearer to 1, it means that you are going to get a very low information gain. Okay. But if your entropy value is nearer to 0, it means that you are going to have a very high information gain, which is contributing more to it. Okay, and what happens when you have the root node? What happens, students, when you have the information gain as a root node? What do you do? What do you do? What happens? Can anybody tell me? Hello? What happens when your information gain, when you don't calculate the information gain and when you calculate the information gain? Hello? What happens, students? Can anybody tell me? Hello? Can you people hear me?
Yes, sir, but we didn't
Yes,
get
sir.
your question.
Why do we calculate the information gain? If we just start to build up the decision tree, what will happen without calculating the information gain?
So if we take up a wrong attribute as the node, then it will keep on going.
Excellent, perfect. Okay, so what will keep on going?
The
The
classification.
decision tree,
Yeah.
they will keep building after building, building after building, building after building. Okay, but if you have a perfect attribute as the root node, then the decision to reach whether he will play or not, given any instances, will end at its maximum. You're getting the point? Okay, so instead of your tree, if you don't take up the information gain, then your tree will be something like this. If you don't have a proper root node. Okay, and you see how many levels it is going. My aim is to just draw the number of levels. Okay, then it will keep going. The decision tree will keep growing. So we don't know how many levels of the depth it will keep going. But if you calculate the right information gain, it might stop somewhere over here, and the entire tree, so that the entire tree you can take up the decision and build up the decision rule for it. Is it clear? Okay, that is why we calculate the information gain. So that which particular attribute of the given data set contributes the best. Okay, plays a very important role in the final outcome. So in this case, we have calculated the information gaze using the concept of entropy. When we use the concept of entropy, we applied through all the 4 attributes like outlook, temperature, humidity, and wind, and we got the outlook as the root node. Okay, and once we got the outlook as a root node, keeping the root node, we can split further. Okay, in Sunny, if everybody is Sunny is telling no, that's all. Can you see the overcast? Overcast, if you see here overcast, 1, 2, 3, 4. And all 4 are yes. 1, 2, 3, 4. Overcast. Is the splitting required over here? Is there a splitting required? Further splitting required over here? Is there a further splitting required over here, students?
No, sir.
No. Yes? Very good. Okay, but in Sunny, there are 2 yes and 3 no's. Is a further splitting required?
Yes.
Yes. Here, 3 and 2. 3 yes and 2 no's. Is further splitting required?
Yes.
Yes. So again, you do the same concept. You repeat the process again. So till when? Till you have all no's in one end and all yes in one end. Okay, the same way till all no's in one end and all yes in another end. Okay, so finally you will end up a decision tree like this, right? All no's and all yes. Okay, so out of 14 records, we have made the outlook as the root node. And because this has the maximum information gain when compared to the other attributes, then we split it up the decision tree using the concept of entropy. Okay, and you know that how to calculate the entropy we have been studying in the class. Okay, and we calculated the humidity, wind, all these things, and then we calculated the decision tree. Now, given any rule, the system will be able to predict whether he will play no, yes, whatever it might be. Is this very clear to everybody? How many of you have understood this? Raise your hands. See, I have not taught you anything new here. Whatever I have explained to you before going to Cat 1, only that again I am teaching. There is nothing new I have taught. And those students, did you get some idea about what is the decision tree happening over here? Hello? The other students? Any idea?
Yes, sir.
I'm waiting. Okay, students. So I have just revisited the concept of decision tree. Now let's get inside the programmatic part. Okay. Now what we have done here is, okay. So basically, to explain you in very general terms, so these are your attributes, right? These are the columns which are called as an attributes. Okay, and these are your tuples. So now consider this is Raj, Simran, and Kumar. Okay, now we are going to predict that whether they will pass the exam or not. So it is either yes, or no, right? So now what happens is, if Raj is sleeping on time, eating well, attending the class, these are the attributes. So if Raj sleeps on time, eating well, and attends the class, he passes. Okay. Then if Simran does not sleeps on time, does not eat well, and does not attend the class, she does not pass. Okay, like that, Kiran. Now, out of all these attributes, which attribute contributes the maximum, which attribute contributes the maximum to the result. Okay, is the root node. How do you find the root node? Through information gain. Through information gain. How do you calculate the information gain? Using the formula called as an entropy. Okay, using the formula called as an entropy. Now, what does the entropy does? You calculate the information gain for this, and this. You get three values, and out of which have the maximum value, you put it over here. So consider you put it over here. So now in this one, you will classify how many labels are there. How many labels are there? Okay, yes, no, maybe, whatever it might be. So you consider no and yes, something like that. No or yes, something like that. Okay, so based on that one, I am going to teach you here. So I have imported pandas, I have imported NumPy, a decision tree classifier to classify my decision tree, and we are going to visualize everything in the form of a decision tree. So all these images, graphics, all what I'm going to use is used in this particular package. Okay, now students, I have downloaded a particular data set called as an iris data set. Just show you the iris data set. If you look at this iris data set, there are some columns called as a sepal length, sepal width, pedal length, pedal width. Based on sepal length, sepal width, pedal width, we are going to classify which this particular flower belong to a particular class, whether it is iris, setosa. There is another classification of a flower called as an iris versicolor, and there is another classification called as an iris virginica. Okay, so three types of classes it might belong to. The flower might belong to any one of these three classes. Okay, these are the three flower names. Okay, iris setosa, iris virginica, and iris versicolora. So based on these values. Okay, so based on these values. So this is the famous iris data set. Okay, you can find it in this one. Okay, so what have I done is, I have imported this data set. For that, you need to have an internet connection. So directly I have used this particular website, and I have stored this data set into this particular URL. Okay, particular URL. Okay, now having done that, what I have done is, okay, I am reading this data set. Okay, this is the data frame. I am reading this particular variable data URL, and I am naming it. Okay, called as a sepal length, sepal width, pedal length, pedal width, and class, and renaming it. Okay, for my purpose over here. Okay, so I am just changing sepal length, sepal width, pedal length, pedal width, and I'm giving a species name called as a class. Okay, I'm changing it called as a class. I'll show you over here. Okay, then what am I doing it? First, let me execute this one. Okay, done. Finish executing that. Okay, so now what am I doing here is, can you see iris.df.head? It is printing sepal length, sepal width, pedal length, pedal width, and which class this, if these values are there, it belongs to a flower called as a iris setosa. Okay, if these values are there, 5.7, 3.0, 4.2, 1.2, it belongs to a flower called as an iris versicolor. Okay, and this some color, other color, other, it belongs to so many other colors. Okay, now what am I going to do here is, I'm just printing what are the different classes it is there. Okay, so in my data set, I have three different classes. In my data set, I have three different classes: iris setosa, iris versicolor, and iris virginica. So these are the three different classes which I have in my data set. So I have three different classes in my data set. Okay, done. Now what am I going to do? Just to make it, what I have done is, I have named this particular class iris setosa belonging to category 0. Okay, everything belongs to category 0. Just to make you understand over here. Okay, all the iris setosa belongs to category 0. Okay, this is just to make you understand. I'm putting it like this. Okay, then all the versicolora, I am putting it that these are versicolora belong to class 1. Okay, and all the virginica belong to class 2. Belong to class 2. That is what I have done over here. Okay, Iris setosa, Iris versicolor, and then I have replaced it, and then I am printing the same. That's all. I'm printing the same. Can you see? Can you see? Okay. Now, what am I going to do? What am I going to do? So now I am printing iris.df.index location. Index location means what? Take all the rows, and from the rows I am taking 0 to 4th column. Okay, 4th column. 0, 1 less, right? So 0, 1, 2, 3. So this is the values I will be taking for all the whatever may be the values. So if you see how many, what is the shape, if you see here, shape, if you see here, 150 rows and 5 columns are there totally. Okay, I'll just show you. So, okay, so my X has what? So all the 150 rows and 4 columns, 1, 2, 3, 4. Okay, then my iris location is what? Either it belongs to, where is it? Either it belongs to class 0, class 1 or class 2. Class 0, class 1 or class 2. It belongs to either class 0, class 1 or class 2. Now I am putting it in the form of an array and I am printing it. That's nothing else I am doing. So X, if I am printing, see what it is giving me. It is just printing the values of X. Okay, all the 150 records. All the 150 records. Okay. If I am printing Y, it is showing me, okay, the 150 record that they belong to class 0, the flowers belong to class 0, class 1 and class 2. Okay, so the iris data shape is, this is 50 rows, totally 50 rows and 5 columns. Okay, the shape is totally 50 rows and 5 columns, 150 rows and 5 columns. Okay, and the 6th column being the, what you say, the category, which particular flower it belongs to, or type it belongs to. Is it clear till now what is happening here? Is it clear till now what is happening here? Hello? Is it clear till now what is happening here?
Yes, sir.
Yes, sir.
Okay. Now, students, now tree equal to decision tree classifier, criteria equal to entropy. Okay, so I can use the decision tree classifier and make the root node as what? There are two ways, right? I can use either the entropy concept or else I can use the Gini concept, Gini index. Okay, so I can use the either entropy concept or the Gini index concept. So I have told you the both the ways in the class. Okay, what is an entropy and what is a Gini index? So Gini index means what you will do. So Gini index I have told you, right? Can you? I hope you have people have listened to that video also. Okay, so Gini index, what it will do, if you take the income, so first you will find the probability of the everything 1 minus of pi squared, so 9 by 14 instances, positive instances and negative instances. Then you will calculate income means high, medium and low. So high and low, medium and low, medium, low, high. Then what you will do, okay, so Gini index of, so totally if I want to calculate a low and medium, so there are 6 lows and 6 mediums and the leftover values. So leftover values of the income which is high, and then you will come up with the value. The same thing you will calculate for low and medium, high and medium, low and medium, high, low, medium. So then you will calculate the everything. So then formula, then you will come up with one particular value, with one particular value. Okay, the same thing you will do for age, student, credit and the other variables. So finally, out of which particular value gives the least impure, which has the most purity note, that particular value will make it as the what you say, as a Gini index. So that is the Gini index that we will see it separately. But entropy, you people know in a very much variety of way. Yes or no? Okay. So entropy, you people know, right? Everybody. Hello. Hello.
Yes, sir.
So entropy. So I am
Yes,
going
sir.
to use the concept of entropy to split my decision tree. Okay, and tree fit dot x and y values I am passing it over here. So these are my values of x. Okay, and this is my decision tree. When these values are there, can you see this entire data set I am passing it? Okay, I'm putting 5.5, 3.5, 1.4, 0.2 means it belongs to category 0. And 4.9, 3.5, 1.5, 0.8 belongs to category 0. So like that, I am passing all the values 4.9, 2.5, 3.3. So this is my x values and this is my y values. So both the values I am passed it. Okay. Tree fit dot x dot y. Now what am I going to do? Did I run? Did I run this? Okay, done. 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 I've changed something, right? Okay. So you can change back to 0 and 1 over here. Shape. Tree. And predict. Okay. Let me just, I don't want to save this. Why this is not running? What did I change? Okay, it's showing correct over here. Versus Iris class Setosa versicolora. Okay, so I'll just explain you, but you can just change it. Okay, so I'll just check what has happened. So instead of zeros, can you see? So it is zeros. This is of a class 1 versicolor and Virginica is of a class 2. I don't know anything, right? There are zeros and ones, were they, right? Okay, fine. So now if I see here, so I am going to use the concept of decision tree called as an entropy to split up my decision tree. Okay, to split up my decision tree. So for that, just expand my 600. Can you see? So it is using the concept of entropy to split the given particular data set called as a decision tree, and it is coming up with a root attribute. Okay, so x1, x2, x3, x4 as and x5 as the features it is taking. It is classifying one particular feature, x2 as the root node. From there it is classifying what is the entropy. So true, there is no, all are true, there is no further splitting. In false, okay, then you have multiple trues and false, it is going to split you further. Okay, so this is how the entire concept of the decision tree, just by using decision tree classifier criteria equal to entropy. Criteria equal to entropy. That is all you need to do, and just try to fit the tree. Try to fit the tree. That is all you people will be doing. Okay, so it will beautifully, it will split the tree into a decision tree and it will give you. Now, if you see the tree, now I am using the predictor model. If you see here, predictor model, and if you see the accuracy, what the system is predicting and what actually it is. And what actually it is. Okay, 100% match. 100% match. Can you see? So the predictor model, when I'm seeing the accuracy, okay, when I'm seeing the accuracy, what the system has predicted and what the actual values it is, right? I have told you the iris data set, right? So given a particular value, see, given the particular value, the system is predicting. Perfect match. Okay, and what the system is predicting, it is a perfect match, so it is high 100% accuracy. Now I am telling my decision tree, listen, you should grow. If you look at this one, till what depth? This is the maximum fully grown tree is first split, level 1, level 2, level 3, level 4, level 5. So 5 levels of splitting is happening here. So the depth of the trees, it goes till 5 level. But if I am telling maximum depth of the tree should be 4. Maximum depth of the tree should be 4. So now I am running a tree. Now I am running my tree. And you see, first level, second level, third level, fourth level. So one depth has been reduced. Now if I use the predictor model, and now if I calculate the accuracy, 0.933. Can anybody tell me why is that so? Can anybody tell me why is that so? Why is that so, students? Why is that so? Hello? Hello? Hello, can you people hear me?
Yes, sir.
Yes, why is the accuracy have been reduced? Why is the accuracy have been reduced, Pen? Can anybody tell me? What is the reason behind it? Because here I am not allowing my tree to grow fully. Okay, see here I am growing the tree till the 4th depth. That's all. Okay, but if I look at this one, if I look at this condition, here I am allowing my tree to grow fully. This is the maximum depth the tree can grow. Okay, this is the maximum depth the tree can grow. It can keep classifying the entropy and applying the formula of information gain, and it can keep growing, and this is the fully grown tree. Just like this. There is a PPT. Just like this. This is a fully grown tree, right? Yes or no, students? Hello?
Yes, sir.
This is
Yes,
a fully
sir.
grown tree. We have worked out every single step till the end. This is a fully grown tree. Now, given any data set, the system will be able to predict, okay, whether the Raj will play tennis or no. But in case if I stop the tree over here, so for example, if I stop the tree over here, I'm not allowing my tree to grow. Now, if I'm giving an input to it, will you be able to predict correctly or no? Will you be able to predict correctly or no? Yes or
Yes,
no,
sir.
people?
We will be able to, sir.
No, Pan, this is not a fully grown tree, right?
Okay, sir. Yes, sir. If it goes to rain, then we will not, sir.
Exactly. Okay, so if I stop here and if I apply my rules over here, and if I'm trying to say for example, outlook, rain, what? Okay, whether he will play or not, will you be able to predict? No, the accuracy will be not right. But if I have a fully grown tree that outlook, rain, wind, strong, then no, I will be able to predict. Or outlook, rate, wind, weak, then I will be able to predict yes. But if I stop somewhere over here, okay, at depth level, say for example, if I stop over here at a particular depth, we'll be able to predict at level 1. If I say the depth at level 1, if I telling you my tree should grow till level depth 1, if I'm not allowing my tree to grow fully, this is a 2-level tree. Okay, this is the fully grown tree. This is a first level split, second level split. This is a 2-level depth. Okay, my full tree, my entire data set is over. Okay, this is just for 14 records. What we are working on with some n number of records. Yes or no? Yes or no? How many of you are able to understand?
Yes, sir.
Hello?
Yes, sir, got it.
So that is why the accuracy have been reduced. Can you see? So now if I am allowing my tree to grow fully, okay, and then if I am running my tree, can you see this is a fully grown tree? So level 1 split, 2 split, 3 split, 4 split, 5 splits. Okay. So now if I am checking the predictor value, it is able to predict correctly. And see the accuracy value. 1. See the accuracy value. 1. Okay, 100% accurate. But now see here, I am just telling you, let's check. Okay, my depth is 2. Okay, my depth level is 2. And you see, my depth level is 2. Level 1, level 2. Now, if I am applying my predictor function, and now check the accuracy. And you see, this is 0.96. Okay, so if I, from 99 it became 96. Now if I say for example depth of level 1, I just want to show you what happens when you stop the tree. Can you see the accuracy, students? Okay, why is that so? Because you are not allowing the tree, you are not trying to construct your tree fully. Based on that, you are not able to take the decisions. But if you are able to construct the tree fully, then you predict, then you do the predictor model, and then you apply the calculate the accuracy, then the accuracy is 100% most of the times. Okay, so this is one statement regarding the decision tree. Okay, so then like that you can calculate the Gini index also. Criteria equal to Gini index also you can calculate. Okay, now another one is
Sir,
yes.
sir, can you explain what is the min sample stiff?
What pa?
Min sample stiff.
Which one?
In the tree, the decision tree classifier, the criterion equal to entropy, comma min samples. It was in the comments part, sir. You commented it. Yes, sir.
This one, right?
Yes, sir. Yes, sir.
Yes, here, because we are not letting the tree to grow fully, the maximum efficiency of the tree reduction is there is a reduction in the accuracy. So in this part, I am allowing my tree to grow fully. But in this part, I am trying to grow my tree till 4 levels. 4 levels or 1 levels or 2 levels. If 1 level, the accuracy is 0.66. I have showed you, right? Getting the point?
Yes, sir. The next line, sir.
Yes, that's what I'm coming that one to the next one. Okay, so the next one is, what is the minimum number of samples which is required? Okay, you can set the bounty. Okay, to split the tree, what is the minimum number of samples, leaves, but to set the bounty? Okay, so now if I am keeping the minimum, 1 second, okay, 50 as my leaf node, and now if I am trying to split the tree, okay, see, it is not at all splitting, because minimum sample leaves is equal to 50. Minimum samples, okay, 50 minimum samples should be there under the leaf, which we don't have that much. Okay, so like that, you can set, okay, how many leaves, okay, that the minimum samples for the tree to itself to get splitted up. Okay, so then the same way you can have the tree decision, what is the minimum sample split? Okay, this is the leaf. There is a difference between the leaf and the sample, right?
Yes, sir.
So this is the leaf. So minimum leaves, if I have 50, then you split the tree, it is telling. This is the leaf. Okay. Now decision tree classifier, minimum sample split. Samples needed to split the tree. How many samples are required? You want to split the tree. If you look at this one, let me uncomment this one. Can you see? Now, so I have the minimum samples. Where is it? Here. Sample split equal to 10. So I can do that. Okay. Like that, students, I can give the decision tree criteria equal to Gini index also. And for Gini index, there are some specific attributes like the purity of the node. Okay, all those things are there. You kindly explore more and add it to it. Okay, and you see what are all the other features you can do with. Now, when you are trying to use this is all totally based on the graphics, students. So when you are trying to use this, what you do is, first you do Conda install GraphicViz. Okay, I'll just show you. Okay. So just type in here. Okay, so type in on the screen. Okay, Conda install GraphicViz. Okay, so this particular file will be installed in my system. If you see, I have installed it under user. Again, the user admin. Okay, Anaconda. Bin, not bin, library, bin, and GraphicViz. Okay, so this path, what you need to do is you need to copy it. Okay, so this is a GraphicViz. So this is just to display the graphics, right? So it takes care of all this functionality, PNG image, right? So this path and environmental variable needs to be set. So once after installing that, just type this code and directly you can use this path over here. Okay, user admin, Conda library, GraphicViz, or else you will not get this tree at all. Okay, it will show graphic problem. Okay, not able to display. So now what this does is, Now what this code does this, okay, it will create a PNG image. This image is in the form of a PNG. You can reduce the height and the width of this image. Sorry. What did I do? So I can reduce the height and the width of the image. Okay, so you can reduce the depth of the tree using this command. Okay, now coming to this, okay, you fill the data down, round off, true. You can add the special characters. It will allow you to add the special characters, okay, inside this block to give a colorful, to give all the entropies of a different color. So all these things will be taken care by these particular lines of code. So for that, you need to install this particular package and work. Okay, is this clear? What is happening here? What is happening here? Hello?
Yes, sir.
So what you do is I'll just see, just replace this values of Sarostra 0, 1. What has happened? I'll just check with this one and I'll upload the code. Okay, you people try it out. Okay, people try it out with this particular data set and also on the logistic regression also. So people have uploaded the logistic regression last class?
No, sir, you didn't provide a link, sir.
Okay, I will upload 2 links. Okay, so one will be for logistic regression and one will be for the decision tree. And on the decision tree, you apply the Navies based classifier also. Okay, so on the particular data set, you give the particular data set and you see which particular random values you pass it. Okay, you say for example 4.8, you see you pass, right, you pass 4.2, then 2.6, then 1.2 and 0.1. Say which particular class it belongs to, what is the probability. I hope you people have studied Navies based classifier. I have already taught you all those things. Okay, so apply the Navies based classifier also, that you do, and Gini index also I have taught you. In this class I didn't teach you, but I have explained you in the clearly in the video. So here basically in lab, it's only the directly I need to enter into programming. Theory, we should know by heart, because if I start teaching theory, then it takes lots of time. For me to explain this, it will hardly take 20 minutes. But since again, there are so many, what you say, people are coming from different backgrounds, I have to at least re-revise the theoretical part as well, little bit here and there. Okay, so kindly pardon me if you are not able to understand entropy information gain, because entropy and information gain itself I took 2 hours or 2.5 hours. So almost 2-3 hours it happened. So for those students who are not able to understand what is an entropy information gain, how to calculate, so I request you to kindly revisit the concept and look at this video. Okay, then you will be able to understand what is happening over here in this entire set of video. Is it clear, everyone? Okay, everybody put your hands down. Okay, how many of you have understood today's class? Raise your hands. Okay, good, fair enough, very good. Okay, so Saturday, before Saturday, 11:59 p.m. kindly please upload. Okay, is it fine?
Yes, sir.
Okay, so kindly work on the logistic regression, kindly work on the decision tree, kindly apply Navy base, and also kindly explore on the other attributes. Okay, so you can explore the other attributes by just going through scikit-learn decision tree, where you will be given multiple attributes where you people can learn through. Okay, just type in scikit-learn decision tree classifier. Okay. Can you see? There are so many attributes. Okay, weights and all you need not go for as of now, because we haven't learned some concept called as a perceptron, all those things. So splitter means which is the best splitter. Okay, so best splitter means based on the information gain, right? Based on the concept of entropy, you find the best node to split. So once you are able to find the best node to split, you can complete the decision tree at the least level, at the maximum. Say for example, if the maximum best possibilities, the 4th level you can stop. So that is the maximum level you can go and build up the complete decision tree. But if you don't find the best splitter, then your decision tree can keep growing after growing after growing. Then it will become an overfitting problem. Okay, so that's the why we go for the best splitter. That is the best attribute splitter we choose at the root node. Only then we be able to categorize. Is that clear, everyone? Is it clear, everyone?
Yes, sir.
Yes, sir.
Okay, pa. So you people can leave. Thank you, students. Any doubts? Any doubts?